All right, good afternoon, everyone. Happy New Year. Thanks for attending today's webinar on residential continuous insulation. This webinar is recorded and the recording is posted to the Code Adoption Toolkit. We also will be launching a new platform soon that will host all of our webinars and with searchability functions. So definitely check that out. We'll be putting that in our newsletter to talk more about it. And if there are any issues with audio throughout this, please feel free to write me in the chat. My name is Erica DeLello, and I'm a Senior Project Manager for NORESCO. This series is sponsored by the Colorado Energy Office with training materials created by NORESCO. So Shauna and I have been working with the Energy Office to provide trainings just like this one. This one is one in a webinar series. We try to do one Wednesday webinar a month, if not more. So this is the first of the year. We've got 2 more lined up for the next couple months, but we will be adding more. So definitely keep an eye out for those. And then there are a couple other items I want to highlight. If you have a specific topic you want to be trained on and a group to do that training with, we're happy to provide that training at no cost to you all. We're also developing on-demand courses, so learn as you go, self-paced courses where you can get CEUs for as well. We're hoping, in the next couple months that'll be launched. And then Sean and I will be coordinating on a specialty series on the R408 section within the low energy and carbon code. Those dates we'll send out within the next couple weeks too. So definitely register for that as well. Okay, let's see here. We also offer tailored group trainings, like I said, or technical assistance for jurisdictions that are updating to the latest I-codes. If you see any of those items that I have listed on the screen that are of interest to you all, or you need support on within your jurisdiction, we're here to help. So don't feel free to reach out to me. I'll put my email in the chat so you guys have it. And yeah, we can do a whole lot of things and more. Okay. Here's a whole bunch of words on a slide for you of all of the latest resources we've created. I just added actually a couple more to this list up at the top here. We've got low energy and carbon code checklists and significant changes comparisons to the 2024 IECC. So some are more in depth, like section by section, but we also have quick 2-pagers if you want to just reference that quickly. We've created a standard performance modeling document. So if jurisdictions would like folks to submit that, so it's more consistent on what you're plan reviewing, we created something along those lines. And then also a residential memorandum of understanding to help identify the roles of approved third parties and jurisdictions, as well as all the other amazing things that are listed on this screen. If there are other resources that you're interested in, there will be a post-training survey at the end of today's session. Feel free to write in, webinar topics, resources that you all are interested in, and we're happy to look at providing those for you all. So let's see what we got here on the last screen. This is probably my favorite resource and is available to anyone working on a project in Colorado or plan reviewing a project or inspecting, you name it. You can submit a question on any of the I-codes, so not just the energy code, and a subject matter expert gets back to you within a couple business days. So it's a really great resource. Even as a homeowner, I've used it as we're doing plenty of remodels at our house, and it's really great to just understand, okay, what do I need to do to comply with code, or what do I need to inspect, or what do I need to plan review? We're happy to walk through all of those items with you. Okay, I'm going to go ahead and stop sharing now, and just a couple last minute housekeeping items before I kick it over to Shauna. We do want to encourage questions, so you can either use that Q&A function or use the chat function, and I'll let Shauna know throughout the presentation. If we do end up getting a lot of questions, then we may hold those questions to the end, but feel free to submit those questions as we go. And then at the end, there's also the ability to raise your hand and ask Shauna a question directly, so I can unmute you. And then I did mention this before, but there is a survey window that pops up following the webinar. If you could please take a minute to provide that feedback, it helps us to continue to improve on these and train on the topics that you guys want to hear about. So, like I said, I've got that poll launched. If you could take a minute to respond to that. And I'm going to go ahead and stop talking and let Shauna present on residential continuous insulation.
All right. Woo. Seems like it's been a while since I've been here. I'm happy to be back. Well, as I was putting this material together, like what all do we need to know as contractors and designers and code officials and readers and everybody else? And so it was really hard to narrow it down to 1 hour's worth of material. So we're going to fly through a lot of different topics, touching on a little bit, but at the end, I have this huge list of resources that is available to you. And I'm going to also email those out to you, that list and all the links. And I also have the probably about 6 or 8 handouts that I can email you with that are just great resources that I use all of the time. So if we just touch on something, no, it will be followed up with some more information moving forward. So let's get started with this presentation. Hopefully today we're going to talk about what is continuous insulation and when is it not continuous insulation. And sometimes people think it's obvious, but it's not. What are different types of the insulation, the benefits, how to verify certain things through ES reports, how does continuous insulation affect wildfire resilient construction, some common pitfalls, and a lot of helpful resources. So let's just dive in. If we look into the 2024 IECC and ASHRAE 90.1 and I think maybe the 18 and the 21 also defined continuous insulation. And one thing that I always tell people is you cannot use this energy code without paying attention to the definitions, right? It's one of the codes that you have to have the definitions chapter open at all times. Conditioned space, it's not what you think it is, right? There's all kinds of things that need further explanation for the energy code, and continuous insulation is one of them. So it's defined as an insulating material that is continuous across all structural members. Okay, that seems like a no-brainer. Without thermal bridges other than fasteners and service openings. It's installed on the interior or the exterior or integral to any opaque surface of the building thermal envelope. So let's look at that, right? What is a fastener? What is a thermal bridge? And when does one become the other, right? And when does it now affect whether or not I can call this insulation continuous? I get this question all the time. So I have a really good friend, Jay Crandall. He has ARES Consulting. He also works for Applied Building Technology Group and does a lot of the work that you find on the continuousinsulation.org website. But he has given me permission to use his information here. But this is a great picture, and it's actually part of a full document on when is it a fastener and when is it a full thermal bridge. And so he goes in here and lets us know that, first of all, a fastener is still technically a thermal bridge, but it's a fastener thermal bridge, not a linear or field or any of that. And if you're familiar with the 2024 codes, thermal bridging starts getting addressed really heavily for commercial buildings, but residential, even some jurisdictions are bringing in the thermal bridge requirements for residential. So it's very important to know these requirements. So a fastener is considered a nail or a screw or maybe a clip, a bracket, or a brick tie, something that might penetrate the insulation, but it doesn't break it up. It doesn't create a big thermal break for the whole. It's just a point thermal break, right? And so you can go through the cladding and the insulation. You can go through, there's all kinds of different ways to do it. You see these hat channels that people use to fur out things. You can use you have wood furring or metal furring, and you see these hat channels. So if I have this hat channel and it's actually you have the insulation and then you have the hat channel so that you can attach your cladding to it, you're still putting this fastener through the hat channel, and it's just going into the insulation into the stud. It is not creating this big thermal break the whole length of that hat channel, right? Just point thermal breaks. So those are all, some people will say, well, that's too much of a thermal break because we have it so often. And so that really is kind of up to interpretation. I will tell you that, you know, the impact of the clip or the bracket or those kind of things, once you get past just a a fastener, you probably need to incorporate some of this into the overall U factor or R value of your wall so that you're looking at the whole assembly and what is in there. When you get a lot of metal in there, it does change the performance of the wall a little bit, but not as drastically as something like this, like a Z channel, right? That actually forms a full length thermal break. This is no longer a fastener. This has now created this insulation to be a cavity insulation instead of a continuous insulation, right? This is a full length thermal break. This is a linear thermal break of the cladding system. So it's just need to know the difference between those, what the code is looking at as far as those go. So right now we have this linear thermal break instead of a point thermal break, where we now have to consider this to be cavity insulation. Once you do that, then you also have to think about, okay, I have cavity insulation on the inside of the building, cavity insulation on the outside of the building. How do I evaluate that in ResCheck or in a performance software? I will tell you that 90.1 in the back, I rely on 90.1 Appendix A very heavily as a plan reviewer because there's all the assemblies and what their U factors are and R values are based on how the assemblies are made, whether it's roof, wall, mass wall, anything, and how it's made up, every single layer of it, and it'll give you the overall end U factor of that whole assembly. It doesn't really have one in there right now for continuous and continuous, but the 2025 version of Appendix A will have continuous and continuous. And so that's nice. We'll be able to evaluate that a little bit more for that U factor. But just want to know, I get a question all the time. If somebody uses these Z channels, can they still call it continuous insulation? By the letter of the code, no. Several codes, right? Not just energy code. Also, the IBC has requirements in there for fastening cladding or furring with when you're using these foam plastic insulated sheathing as continuous insulation. So just know you're going to find, I'm going to reference a lot today at continuousinsulation.org. They really have, the industry has really stepped up. A couple of years ago, they sent me some questions saying, what are you struggling with? What are code officials struggling with? What are designers struggling with? What are builders struggling with when it comes to continuous insulation? What do you need from us? And man, I let them have it, a 1 hour webinar on we need more details. We need more of this. We need more resources. And man, did they step up. They have so much information. And so continuousinsulation.org is one of the places where they've really stepped up. And so I'll show you more of that as we go. But what is cavity insulation versus continuous insulation? That's another question that I get sometimes. Or if I'm reviewing a ResCheck or a performance report, somebody calls it continuous insulation. I go to look at the plans. I'm like, yeah, that's not continuous. What is it? It's not a product. A lot of people think that, oh, I'm using rigid foam board, that's continuous. I'm using a bat of insulation, that's cavity. It has nothing to do as well, not maybe not nothing, but not as much to do with the material as it does with how you install it, right? So I can take rigid foam board and apply it continuously and have it be continuous. I could also cut it and put it in between two framing members, and now it's cavity, right? I can have I can have blown in insulation is most of the time cavity. I have yet to see a continuous blown in insulation, other than sometimes in the attic where you're gonna you fill up to the truss bays with insulation, and that's cavity, and anything you do over the top of that might some people consider continuous. And so that's about the only time I've seen that. I might have spray foam. Spray foam again is one of those products, unless it's in like a rafter seal. Not even that. Very rare am I going to get continuous because I would have to go over the studs to make it continuous. The whole idea of continuous insulation is to stop that thermal bridge at the stud, right? At the framing. So I'd have to go over that, which means I'm not going to install some drywall or something. And so there might be some issues there. I could have fiberglass insulation, batt insulation that is installed in a cavity and it's cavity insulation, but I also could have it hanging continuously on a wall, like in a basement. I see those, and you hang it continuously and now it's continuous insulation. So just keep in mind the difference between cavity and continuous there.
Hey, Shauna, we got a question.
Yeah.
More of a clarification. Double wall framing, can that
Yep.
be continuous?
We're going to talk about that in about 2 slides, probably, or 3.
Perfect, thank you.
That it?
That's all.
Okay. All right. So we're going to talk about every kind of continuous insulation that I could think of anyway in just a minute. A couple things that I want you to pay attention to, especially as a plan reviewer, and the more we start trading things off in the code or trading things down, this becomes a little bit important. So, I have this house and it's covered with continuous insulation. This is a house that we did in a field study, I think in New Mexico. Might have been Colorado. Anyway, when you get up close and personal, every insulation has to be marked. The code says how it has to be marked with its R value and all of that. So it's interesting to see on some of these insulations where you have every manufacturer and every type of exterior or continuous insulation can have a different R value per inch. And even with this one manufacturer, their different series, the 150 series versus the 250 series has a different R value per inch, right? And then it also acts differently at different climates. The colder it is, the more it's resisting that heat flow. And so you have a higher R value, right? Whereas in warmer climates, you might have a lower. So how do I know what the true R value is of this? There's a couple things to know. So if somebody says on their plans, oh, I have 4 inches of EPS or 4 inches of polyiso or whatever. That doesn't tell me anything because it could, depending on the series, it could have a different R value per inch, right? The different brands could have a different R value per inch. So you would really need to look at that, and you would have to, because the code tells us in chapter 3, which hardly anybody ever goes to, right? That's all your install instructions. But in chapter 3, it tells us how R value for this code is determined, which requirements it uses, and that it is determined at 75 degrees, right? And so I would go back here and I would use these R values. And so if they used the Series 250, I would count this as an R 4.4 because that's more of the average for the year, right? And so I could use this R 4.4. So if they told me, oh yeah, my insulation is R5 per inch. Well, it is an R5 per inch in an extremely cold climate at R2 at Series 250. But on a normal day by the code, it's a 4.4. So Is it that huge of a difference? Maybe not, but it could be the difference in pass fail if they're doing like res check or they're doing a performance report where they're counting on that R5 and barely passing with it. So just something to pay attention there. The other thing to pay attention is when you call insulated siding continuous insulation. Poor Matt Dobson with the insulating siding guy, he and I fought many a year at the code hearings because I just didn't believe that insulated siding should be called continuous insulation. And many years it wasn't. But in the 2024, you can count continuous insulation. You can count insulated siding as continuous insulation. Again, in chapter 3, it has to have the R value has to be labeled as on the product, and it has to meet a certain standard, and then it also has to be installed according to manufacturer's install instructions. That's just in chapter 3. But because of this continuous insulation, here's another slide that I use for a different class, but I just wanted to show you because it has a better picture that this insulated siding, his thickness is different and it overlaps and there's airspace and there's air movement. So the code, the agreement between all of the people in the code hearings was if you want to count it as continuous insulation, you can, but you have to reduce it by 0.6, the R value by 0.6. Most of these come in at an R2 on the package. You'll see an R2. So now it's a 1.4. So that's what you're looking at on ResCheck or something else. So make sure that you're paying attention to that when it comes to that. So, all right, let's look at the different kinds of insulation. There's a bunch of different insulations out there, a lot of rigid foam boards, some wools, some, bats, there's all kinds. So let's just kind of go through this. I know it's a lot of info on a slide. We're just going to focus on one thing at a time. This XPS, it's kind of known for its strength and durability, right? It offers some pretty good moisture resistance. And so it's really actually pretty popular for below grade and exterior wall applications. It's about an R5 per inch, depending on the manufacturer and the model, if you will. So it was about an R5 per inch. It's kind of a mid-range price between EPS and polyiso. It kind of fits in there somewhere. Um, I will tell you though, one thing that I think that people don't realize about XPS and even some of the other insulations is that while they kind of are slow to absorb moisture, they're also very slow to release that moisture. So, and when it holds moisture, insulation holds moisture, it loses its R value. And so this insulation, even the manufacturers, they won't warranty it for more than 90% of its R value because it loses R value over time because it holds moisture. And so, and the longer that it's in, the less they warranty it, right? The warranty goes over time, just like the R value. And so just something to keep in mind about that one product. EPS is expanded polystyrene, right? It's pretty versatile. Its R value is a little lower than the XPS and the polyiso, coming in at about an R 4.6 per inch. Still pretty effective choice because you can use it in a lot of different applications. It's rigid, it's tough, it's closed cell foam, but also the way that it's made, it doesn't absorb that moisture, right? And so it can be warranted. The R value lasts over its service time. And so that's good, something good to know about the EPS. It's pretty versatile. You can use it in floors, walls, roofs, below grade, all kinds of things because it dries quickly. So it's a good moisture management tool. When you come to GPS, graphite polystyrene, a little less common, don't see it very often. It's about an R5 per inch. It's this factory laminate on top of insulation, right? So it's like this, it forms this shield that reflects radiant heat away. It's kind of like taking a radiant barrier on top of your insulation. And so it increases the resistance to the heat flow a little bit more. Where I do see it used is in confined spaces because it's thinner and less dense than some of the other insulations, so it's a little bit easier to install. Polyiso, pretty common. Why is it common? Because it has an R, it's probably got the highest R value per inch, right? It's around R6 to R7 per inch in most of the applications, so it's pretty efficient material. It is lightweight, moisture resistant, fairly easy to install. However, um, well, historically, it was used in roofs, but now there are some manufacturers who also have it in walls. But it is like XPS in that it absorbs that moisture and over time loses its R value and won't get its warranty for the full R value. It will decline over time. So, what do we know about mineral wool? Mineral wool is great. It's if you're requiring fire resistant insulation, mineral wool has a combination of things, right? It can do ignition resistance, thermal performance, soundproofing, all kinds of fun stuff. It's sold usually in either like a rigid bat or a board, usually in wall and attics, but starting to see more and more of the loose fill material being blown into some cavities. So a little bit versatile there, but starting to get more into that fire resistant construction. What about a double wall? There's some great info on double wall. I can't get into it like hugely. I did a webinar, I think it was last year maybe, on advanced framing techniques that really included double walls, but there's some great information by PNNL also on that. So pay attention to those. But the way the double wall works, it depends on how you build them. A double wall doesn't automatically give you continuous insulation. There's so many different ways to do it. Common one is to build two walls, offset the studs, right? Offset the walls. So they're cavity insulation in both walls, but the studs are offset so you don't have that constant thermal bridge. That's one way of doing it. Another way that I've seen is to build one structural wall with cavity insulation and then a layer of continuous like rock wool or something on it, a mineral wool done continuous on that wall, and then build an interior wall, a second wall that just does your like your plumbing and mechanical and electrical. And so that one wall that holds your insulation also has a layer of insulation on it. There's a couple different ways to do double walls and call them continuous. It's the idea is that you have a continuous thermal break, right? You do not have thermal bridging where you have that heat loss through the thermal envelope. Bats can be done, like I say, you can hang a bat continuously or you can shove a bat into a cavity. So there's lots of ways that bats can be done as cavity. I mean, as continuous. I mostly see that in basements or crawl spaces. Spray foam, spray foam. Can you really do spray foam continuously? That's one of those, like I say, you'd have to go around all the studs. You might, it just depends on maybe if you were doing that double wall system and you could fill the cavity plus go over the studs, then you would have cavity plus continuous and then build your second wall. Maybe you could do it that way because you would put the drywall on the inside of that second wall. But it's harder to get spray foam or blown in products like that to be truly continuous. Wood fiber board, that's the insulation that's like certified softwood chips. I like it because they're using the wood chips that are left over from other, lumber production stuff. And so they create it into this loose body fiber that they use. The nice thing about it is a lot of times they'll mix it with borate. And so now it becomes flame retardant and it also resists mold and mildew. So I don't see it used as much, but we might see, with this push for wildfire resilient construction, we might see some of these other kinds of insulations making their way into the mainstream. So I don't know. I put other on here because I thought maybe if you have a chance, you could tell me some other things that you've seen. One thing I would say about this wood fiber board is with the borate in it, it becomes a class A, but even without the borate, it's still a class B. And so, uh, class B flame spread, sorry. And so it's still a pretty good product on it, but I'm
Hey,
sure there's other.
Shauna,
Yeah.
I've got another situation
Okay.
question for you.
Oh,
Um, we run into challenges getting continuous insulation when dealing with pre-engineered metal buildings where they use final face bats that get wrapped over steel purlins,
yep.
which compresses the insulation but is not technically a pure cavity insulation
Yep.
condition. Do you have
Yep.
any tips?
I do. I mean, that's more of a commercial situation, but I can tell you that when you're looking at the prescriptive table in the code, when it comes to commercial buildings and especially metal buildings, it'll tell you, you know, you have to have a double layer prescriptively. You have to have a double layer insulation, one draped over the purlins, one parallel to the purlins, and hopefully a thermal block in there. But and it gives you an overall R value that you have to have. And when you look in the U factor table, it gives you a U factor for that whole assembly. Where people are making the mistake is going through and telling people when they go prescriptively that they have to account for the different R value at the purlins than everywhere else, and that is not true. If you look at the footnotes tell you that it has to be installed per ASHRAE 90.1, you're going to go look in ASHRAE 90.1 Appendix A, and it gives you the overall U factor, knowing that you're going to compress that insulation at those purlins because the code told you you had to, right? And so it's asking you for that overall, when it asks you for an R19 plus an R7.5 or an R19 plus 11 or whatever, it knows you're going to compress it. It told you it had to, right? It's the only time you have to look at what it is at that compression is if they use a value other than what's in that prescriptive table. Then they need to go to ResCheck or ComCheck or appendix or ASHRAE or something to figure out a way to model that to show what it is now that they used a different level of insulation. But I will tell you, in ASHRAE Appendix A in the back, it gives you that metal roof assembly or a metal wall assembly with the double layers that are compressed, and it'll tell you here's the U factor for every kind of insulation combination you could ever imagine in there. It'll give you the overall U factor so that you could at least see, is that the U factor that they used in ComCheck? Is that the U factor they used in their performance report? So please don't hold them to a different requirement for those places where they compress them because the code tells them they have to compress it and it asks for an overall U factor knowing that they're going to compress it.
Thanks, Shauna.
Yeah.
That's very helpful. I got one more question for
Okay.
you. We are used to seeing exterior continuous insulation. It appears the code doesn't care if it's on the inside of the bat insulation or an exterior wall, on an exterior wall, sorry. Is the dew point taken in consideration?
Mhm. Not in the code, but it does in that's the designer's job, right? Is to, and we're going to talk about dew point here pretty soon. The designer's job is to calculate that dew point and figure out how much insulation they really need on the outside of the building. The code can't do it because there's just way too many combinations of things that could be going on. What's the thickness of the framing? What's the material of the framing? Is it 16 inches on center? Is it 24 inches on center? What kind of insulation are they using in the bat? What kind of insulation on the outside? You know, like there's way too much to think about to calculate that. You can go online and Google a free dew point calculator. The more insulation, continuous insulation you get on the outside of the building, it's going to move that dew point to the outside, and you don't have to worry about what's going on the inside anymore. But that's for the designer to calculate based on how they've designed that whole assembly to be built. like I say, the code just couldn't, we'd have a code book you'd have to carry around with a wheelbarrow if we had to try to put every kind of scenario in it. And so it really does leave things up to the designer. Great question.
Perfect. Thanks, Shauna. And it looks
Mhm.
like Brad put a calculator in the chat for anyone that's interested.
Marvelous. I love it. I love it.
All right, I'm going to hold off on asking you questions for a little bit so you
Okay.
can make some moves through these.
Yeah,
But
try to
folks,
get through a couple of these. There's so much
yeah,
information. That's
folks,
why I say this could be a whole day class. I'm just touching on things, but I have lots of resources for you at the end.
great.
All right.
Okay.
Why continuous insulation? Well, people think, okay, continuous insulation, it's it's just more insulation, so there's probably better energy code performance. That's true. The building will perform probably a lot better for the thermal break uh, that you're giving it, right? Or for the yeah, but it also has a lot of other benefits to it. It reduces the energy cost of the building, not just, well, because we're not heating it and cooling it as much, right? But if you think about that, just that benefit alone, a lot of people think you're not thinking big picture or whole picture, right? We're reducing the cost of our energy bill because we're not having to heat or cool as much because the building, you know, I heat it to a certain temperature. That building is super insulated. It stays the same temperature for a long time. I don't have to keep, my furnace isn't constantly turning on, right? And so what does that do? That also means that I probably can use smaller heating and cooling equipment, right? I don't need as many BTUs to heat that space. It's not going to run as much, right? So it's not just an energy bill, but it's also the cost of the mechanical equipment and some other things that we're going to talk about. So it's a big picture. I know when I was writing the 15 or involved in helping at the national, writing the IECC, the 15 and the 18 and the 21, I sat down a lot with Joe Stieberg. We would meet and he would be talking about his vapor proposals, and I'd be talking about insulation proposals, and then we'd meet in the middle and talk about uh, mechanical ventilation proposals. But he was very adamant that, as someday we could take away manual J. You don't have to size your equipment because who cares what size equipment you put in there? If you build a really great envelope, it's hardly ever going to run, right? And so, but we're just not there yet, right? We just can't get that. All we can't get past the cost or some of the other things with continuous insulation. So it's a big picture. Code compliance, sure. There's times where if you went prescriptive, it's going to require you to do 2 layers of insulation, a continuous, a cavity and a continuous or something. We're getting more options in there, so it's less times that it's required. But most people will use a trade path and even then, you're going to get a way better trade for continuous insulation than you are going to get for cavity. So code compliance, it's pretty easy. Thermal bridging is one of the big ones, right? Like wherever I have studs or wherever I have metal or whatever I have these things that or concrete or patio or concrete that goes all the way through the whole thermal envelope, right? I have these bridges there where I'm losing all of this heat loss. And so continuous insulation stops that. And so it offers some great things there. Definitely reduces the moisture damage, minimizes moisture, minimizes thermal stress, preventing mold, rot, material degradation, and then enhanced comfort. Again, insulation more stable to the indoor environment. You turn your heat on, it stays that. It's just not changing all of the time. One thing I will just say is it's just like everything else. The tighter we make these buildings and the more insulation and all of these, they all go together. You cannot ignore mechanical ventilation. You have to bring in some ventilation, right? So just keep that in mind. Another thing is it is the key first step in building electrification, right? If you want to say we want our buildings to be all electric, then you better make sure that you're building buildings that don't carry very much load over with them, right? If I build this is something that we, in Aspen when we were writing the 2021 codes, we said the city council wanted all electric, and we said, wait, we have to start with a really good thermal envelope. Build a really good thermal envelope so that we can bring those loads down, so that we aren't talking about huge oversized panels and oversized transformers and crashing the grid, right? Let's bring the loads down first through a great thermal envelope, and then we'll talk about going all electric. It's one of those first key things that people need to be doing, and so I think people forget about that. Some things about thermal bridging, I always talk about this in my building science classes, is, we get these, we look at the structural provisions and we think, okay, we have this window, framing in this window, one king stud will be good. Well, structurally, two king studs probably better. Well, six got to be really, really good. Well, what about 15? Well, what is that doing to our envelope? Right? Not only is it overkill structurally, but we get these things like stud packs and things, right? And what are they doing to our building assemblies? And so if you think about this, wood is only about 1 R value per inch, whereas our insulations that we saw are between 3.5 to 7. And so we want more insulation than we want wood, right? And so what ends up happening, you can see on these buildings where you can see every single stud because we have all of that thermal bridging. There's only 1 R value per inch right there. So we're not talking about very much resistance, right? So we end up having all of this heat loss right there. We don't get that if we put this continuous insulation on the building, right? And so we end up with a much better U factor and better code compliance for sure. You're going to always pass much easier with continuous insulation than without it. Uh, but there's a couple of things that I think people don't pay attention to, like these top pictures. I just take these pictures while I'm out doing building studies, and Robbie does with me too, and some other folks that we go do these building studies and get a lot of pictures, which is fun. But look at these top pictures. What is the difference between this house and its continuous insulation and this house with this continuous insulation, right? Why did this house have to put Tyvek on the outside? Because they didn't seal all the joints and seams, right? So now they have to have a water resistive barrier. Where this house sealed all the joints and seams, so they didn't have to add a product to it. It's a lot of times people say, "Oh, the energy code is just getting so expensive." Have you looked at these job sites? You have a material that will serve 4 or 5 purposes here, but you add other stuff to it just because it's habit. You could get away with one product that serves many purposes, right? Or you ever walk in, I want to teach a full day class, I could show all these pictures of here's why people think the code is so expensive, and it's got little pieces of spray foam blown everywhere, but it's not doing anything, right? Like utilize what if you're going to put it in, then make it work for you, right? And so there's you can have one product that has many benefits. You already have a water resistive barrier. It could be, depending on how it's installed, and you got to pay attention to the joints and seams. Maybe look at that. One thing that I do is ask for the ES report, the ICC Evaluation Services report, to see if it was evaluated as a water resistive barrier, sorry, and if it has been how it has to be installed to actually be called that. But it could be the water resistant barrier, it could be the air barrier if every joint and seam was sealed. It could be your vapor control layer, right? Controlling vapor in and out of that assembly, both ways, depending on whether it's hot or cold outside, right? And definitely your thermal control layer. So if I have one product instead of 4 different products, why I think people are not using it to their benefit. Oh, we have to complain about putting in continuous insulation, but you don't have to do all those other things if you do it correctly, right? And so thermal bridging is one of the big things. Again, Jay Crandall, my buddy, if you've ever been to the Educational Institute, we have a class. He's taught several classes on continuous insulation or building thermal envelopes. He's such a good resource. But I love in this presentation, and you're going to get this presentation. You'll get his presentation on thermal bridging, the whole PowerPoint. He sent me the whole PowerPoint, right? That you can have that's small details with a large impact. But it was interesting and to see in there, you see in the table it says you have a R20 or an R whatever or a 20 plus 5. Well, people think that an R25 is equal to an R20 plus 5, which is totally not true. An R25 is in the cavity getting all this thermal bridging, with a lot of thermal bridging. And so an installed in all of that wood as a cavity ends up being about an R19 when it's all said and done. An R20 plus 5 that breaks up the thermal bridging and gets installed is like an R22 because you still have studs and stuff in there. But so you see that an R25 is not the same as an R20 plus 5. They're very different in how they're installed. This is why we're trying to get people to think, to shift from looking at the R value of the insulation and start looking at the R value of the entire assembly of how it works together. Then you're really going to see where continuous insulation plays a role in there. So be sure to read through this. There's some great information in there on thermal bridging. Ways to mitigate thermal bridging, of course, reduce your framing factor. Go from 16 inches on center to 24 inches on center so you have less framing. That's one way of reducing some of that. You use double stud framing, something like that. Use low conductivity structural materials, things that don't use metal, right? Apply continuous insulation over it, or use low conductivity fasteners. Some other things to think about is, we see these metal fasteners. Now there are all kinds of new fasteners, or even these little plastic sleeves, so that your fastener isn't even as long, so you have less metal. There's thought that can be in this. The code isn't going to require it. There's too many ways it could be done. But there's lots of ways if you do these to drop that U factor of your wall, increase the R value of your overall wall. So, and deal with those thermal bridges. Couple things on ES reports I just want to point out. If we say I want to use my continuous insulation, my rigid foam board as a water resistive barrier, or I want to use it as my air barrier, can it be done? Find an ES report, right? So this is like Insulfoam, and it gives you Insulfoam, EPS, RTEC, and Thermal 3HT. All of those evaluated here to these editions of the code. And here's, this one is just, it applies to those, right? And so it'll tell you what code it was evaluated to, the properties it was evaluated for, and any, like this one, even the green codes, it's got the California codes, it's got the NGBS, the ICC 700 codes that it's evaluated to, and it's going to look at it. It looks at the uses, right? How is it to be used? Okay, I've got this ES report, and here's the uses. I can use it, right? I can use it as a non-structural thermal insulation in cavities or ceiling assemblies, roof, as exterior insulation around slabs, walls, whatever, it gives me the codes. It gives me, I can use it can be used on the outside faces of exterior walls of 5B construction or anything built under the IRC, used in attics and crawl spaces, can be used, it gives you all of this information of how it can be used. Then it also tells you it can be used as a water resistive barrier if it complies with section 4.3, right? And so you go here's 4.1, all the general about installing it, how it can be used, everything general about it. Here's section 4.2 if you want to use it in an attic and crawl space and not have to cover it, right? It can be used in attic and crawl space without covering applied as long as you do these things. You can use it as a water resistive barrier if you install it this way, these sides, this kind of fasteners, these, blah, 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 install it this way is your water resistive barrier. So it's really important to pay attention to those install instructions and the ES reports to see if it can be a code compliant water resistive barrier. Another thing about ES reports just to pay attention to is sometimes they have a lot of proprietary information. So you could see this is right off of their ES report that talks about, uh, maybe we have RTEC or RTEC tape, Polyguard, polyethylene, right? Like, so there's some things in there that are pretty proprietary. So make sure that that's what they're using, unless somewhere in the wording it says or equivalent. So, um, all right, let's talk about continuous insulation and wildfire resilient construction. If you're in a region that's designated, or pretty much the whole state of Colorado is in some form of wildfire interface zone, whether it's mild, moderate, or high. I don't even know very many mild anymore. Just about everything's moderate or high according to the state. So we have to think about fire exposure, right? Then they burn fast and with high intensity and end up with a lot of damage. And so what do we need to do? There's a lot of things out there. This right here, and you're going to get a copy of this. This is the Wildfire Resiliency Code requirements for the state of Colorado, talking about the structural hardening. And we get a lot of questions about whether we can still use continuous insulation and does it conflict with the structural hardening requirements. And I'm just going to say, it depends. It depends on what you want to build, right? For the most part, it's like anything else. If I'm going to use a rated wall, I'm going to build that rated wall. If the rated wall assembly says that I can use continuous insulation in there, then I can. If not, then I'm going to put it on the other side of my wall, right? I'm not going to include it in the assembly. I'm going to attach it to the assembly, right? So there's different ways to do it. I could build a listed rated wall and then add insulation, or I could build a wall that's completely non-combustible, or like there's all kinds of different ways to build a wall. And so this code looks at that too. I have an exterior wall assembly of 1 hour, rated from the exterior side, non-combustible, heavy timber, just non-combustible materials. There's a difference between, non-combustible and non-combustible materials from the exterior side, fire retardant treated wood, ignition resistance, right? And then it gives you some exceptions. Another one thing to note here is for the next section, the subsection has exterior wall coverings, right? Here's your wall and here's your wall coverings. It lets you use vinyl siding as long as you did item 1 or 2 up here. So you would build a 1 hour fire resistant rated wall or a non-combustible material, then you could put vinyl siding on the outside of that. So that, I mean, it just goes to show, like, if I built that rated wall or I built a non-combustible wall, I could still have some continuous insulation in there. I might change the type of insulation I use or change my assembly of how I'm going to do it, but I can't just say, oh, this wildfire code now says I can't use continuous insulation. That's not true at all, right? We're working with Colorado Division of whatever. Yes. Anyway, I've been working with Chris, trying to get some information that we can put out to you on maybe different types of assemblies and what would be considered allowed. But there's a lot of info out there already, right? Here's buildingscience.com. Here's Joe Steebrook. He's got, if you haven't been to buildingscience.com and sign up for their insights, please do. You get on everything, and Joe's pretty humorous, right? But this one is, I want to build a non-combustible roof, but I want it to be vented. Can I do that? Sure, if you do it this way. It's got all the details, got all the things. It's got a little humor. Like, he starts this whole inside article with saying, if you take rock and you melt it and you blow air through it, then you get fluffy rock. And fluffy rocks don't burn. If you take gypsum and you make it into sheets, you get sheet rock. And guess what? Rocks don't burn. Also, metal doesn't burn. Okay, some metals burn, but you get the idea. If you take wood that burns and you add rock and metal to wood, you get wood that maybe doesn't burn, right? He said we could be really onto something. There are all kinds of places where we have to deal with wildfires and all kinds of places where we build right next to our neighbors. Where we build next to our neighbors, we have kind of decided that it's a good idea if their house catches on fire, ours doesn't, and vice versa, right? And like he goes into all this humor before he gets into this technical stuff, right? So just be sure you're checking out his articles. But there's all kinds of details at buildingscience.com. He's got it for walls. He's got it for, here's another insight, wall assemblies with non-combustible cladding, fire retardant or fire resistant continuous exterior insulation, how to install it. And here's the assembly, right? You can also go to continuousinsulation.org, right? Click on applications, go to their fire performance, look at all of the fire performance with using rigid foam board and all these different assemblies and how to meet NFPA 285. You could go to Rockwool. I'm not picking one organization. I'm going to check them all out, right? I'm going to go to Rockwool. They've got a great website. I can go to resources and tools, look at fire performance, and look at wildfire resilience. This is an amazing technical bulletin. I sent it out to many of you a couple months ago, but it will be sent out to you again. It's a great bulletin. It goes through, gives you all the kinds of details for different kinds of assemblies, how to put them together, how do they work together. And so make sure you're looking at that technical bulletin. Like I said, I'll send you a copy of it. There's FEMA. So this is a good resource. FEMA's got this Builder's Guide to Construction in Wildfire Zones, talks about how they assess all the different stuff, planning, defendable space, structural hardening requirements. They have a lot of resources in there. Check out the insurance companies, right? The Insurance Institute for Business and Home Safety. They have put out a wildfire bulletin, right? They have a series on wildfire. Part 2 is the built environment and talks about all the ways that fire hits, whether it's embers or flame or heat exposure, radiant heat. Talks about all these different things, gives you resources and tools for them. Right, we've analyzed these kinds of disasters, and here's some different tools: wildfire prepared home, model ordinance you could do for a wildfire code. They have this handy map that shows, I think is interesting. It shows, if you were looking at the whole map, it talks about dark blue or light blue is people who have a statewide code and are actually enforcing it. Dark blue is we have a statewide code and it's not really uniformly getting enforced, and black is we don't have a statewide code. Here's Colorado, we don't have a statewide code for all the codes. Red is wildfire occurrences. Yellow is tornado occurrences. And then you have some hurricane occurrences down here on the coast. But so it's interesting, these reports and things. They have a great website too with a lot of good information. So everybody out there's got information on it. So I know everybody has a billion questions on it, but there's so many resources. Couple things: avoid some common pitfalls. Stagger your joints in continuous insulation to minimize thermal bridging. Make sure all the seams, joints and seams are tight, tape sealed, however the manufacturer requires it. Be mindful of material that can conduct heat, such as metal fasteners, structural elements, right? Identify any wall penetrations, including vents, pipes, make sure they get all sealed up, right? Select fasteners that are compatible with the insulation material and the building substrate. Improper fastenings lead to gaps in compression. Incorporate proper flashing and moisture barriers to prevent water intrusion. Here we go. Calculate the dew point. Joe has a building science insight on hybrid assemblies where he's talking about dew point and how much insulation you put moves your dew point and where it's at and how to build those assemblies. But Brad put a dew point calculator in there. That's something for the designer. That's not a code requirement that we can do. Foam sheathing is not a structural wall bracing material. We really need to make sure that you are using, you might have an insulated sheathing that you're using, but the insulation itself isn't the structural wall bracing that you use, right? And so pay attention to that. Don't rely on foam board for wind resistance. I might have some wind. Some people install their insulation right over the framing. That's not going to get you wind resistance. You have to have that sheathing for that. Make sure you're looking at IRC 316, IBC Chapter 26 to understand everything about foam plastics if you're using that kind of continuous insulation. And then check out IRC Appendix BN, Extended Plate Wall Construction, where it talks basically about I have 2x6 top and bottom plates, but 2x4 construction so that I have uniform wall by having space for my continuous insulation, and it has all it's a prescriptive design for extended plate construction. That's an appendix now in the 24 IRC. So pay attention to that. Just a couple things. I know we're getting there. Avoid drive-by inspections. This was a house I was looking at in another state. Drove by, I was like, oh yeah, they did the whole house in continuous insulation. No, they didn't. That is paint. Now, you could say, oh, they were trying to cheat and think that you were just looking at the paint. It's actually water or fluid applied air barrier. But it does look like, at first when I saw it, I thought that they were just trying to cheat the system and make me think that they were doing insulation. They weren't. All right. Although traditional insulation methods are quicker to install and have lower upfront costs, the long-term benefits, hopefully you understand, can outweigh, because it's not just about the R value anymore. I have this video, but I'm not going to show it. It's Jay Crandall walking through how to use their website. But can you just look at this and see that they have material on there for every different trade and every kind of thing. There's resources. There's so much information up here. This website alone is one of my new go-tos. I love it. So helpful. Not just for they have all kinds of calculators in there of how to calculate all the layers of the assembly together to get your R value or your U factor, but they also have articles in there on wall bracing and like all kinds of things. So make sure you're checking that out. And then I'm not going to show that. And then this is the list of all of the resources that I'm going to be sending to you. So look for those. All right, I think we have some questions. So please know, again, not enough time to get through everything. I will go through go through as many questions as time allows, but you're going to get so many resources. I hope that you utilize them because they really are helpful. Whew.
Awesome. Thanks, Jana. That was great. We could always do a part two. So
Yeah.
if you're interested in that, make sure to put that in the survey. I see one question, and if anyone else wants to raise their hand or write questions in the chat, Sean and I will stay online for a little bit. Excuse me. Okay, curious your thoughts on slab on grade and if the ICC expects this to be considered continuous insulation like ASHRAE 90.1 does. Additionally, the 2024 IECC slabs on grade commentary specifically states critical to the installation is the thermal break required by code. A brick ledge creates a challenging detail in considering continuity.
Yeah. There's a lot of fun stuff about slab edge insulation. I don't think anybody loves it. It is, show you all kinds of thermal imaging where you can see the heat loss right there at the slab. Are there other places in the building I'd focus on first and make sure I get them right? Absolutely, but I'm not going to ignore slabs. It is continuous insulation because it's insulation on the perimeter. It's supposed to be continuous insulation at the perimeter there. But however, we've come up now with new ways of installing, and as technology advances and details advance and people put more thought into it, it becomes a little different. It's supposed to be continuous. Maybe this is one that I do in my residential IECC classes, and I show you some different ways to install it. where you can install partway on the outside and partway on the inside and still get continuous because you have it both places depending on how you install it. You have to look, you have to have it continuous from the top of the slab down, however far that is. You can have it partway on the outside and partway on the inside, but it has to be continuous from the top of the slab all the way down. It's 48 inches or whatever depth you are, depending on where you're at. And so, unless you trade it off, that's prescriptively, right? You could either trade it off or you can trade down. You have to still, even if you trade down, you have to start at the top of the slab, but you could go down only 6 inches or something and trade the rest off. That you can do in the 2024. However, there are new details out there, even buildingscience.com. Everybody has these details. One thing that I have learned is run the details by the structural engineer. Because the structural engineer is calling for continuous insulation, but then the architect is coming up with some funky designs that didn't get approved, especially when you're talking about a bottom plate that's hanging over and isn't centered on the wall, so now your bolt isn't in the center, or it's hanging over and it's resting on the continuous insulation on one side or the other or whatever. Those details are getting kind of funky. And so we need to make sure that the structural engineer buys off on whatever you're doing. But it is hard to do. There are, just like everything else, there is a lot of resources on how to make continuous insulation work. Um, it's one of the number one reasons people use CommCheck or ResCheck to get out of it, just because they don't want to make it work.
Makes sense. All right, I'm gonna stop the recording, but I got one more question for you. Give me 1 second here.